Okay, let's take a look at proving or disproving an identity. An identity is nothing more than an equation, such as, let's say, tan theta times secant theta, for example, equals sine theta times secant squared theta. So if you were asked to prove this identity, what you'd want to do is prove that the left-hand side of this equation is always equal to the right-hand side of this equation, no matter what theta is. Okay? So you could not just plug a value of theta in, see that it's a true statement, and say, well, that's true then. It has to be true for any value of theta. So you have to prove these more generally. So let's look at methods of proof. So this is just an example so you know what I'm talking about. By the way, this is an equation. If the directions for this equation were solve, that would be a totally different problem, right? You'd be trying to solve for the variable theta. You'd be trying to do things to both sides to get theta by itself. That's not at all what we're doing when we're proving identities. We're simply trying to show that the left-hand side is always equal to the right-hand side. Alright, so method one for proving an identity. One method for proving an identity, let's not call it method one, is to take the left-hand side and rewrite it, manipulate it in multiple ways, maybe through multiple steps, to eventually change it into the right-hand side. So what do you think I mean by change the left-hand side? We're just changing the way it looks, not its value, right? So if you want to do something to an expression and not change its value, you might multiply by some form of the number 1, right? That wouldn't change its value, but it can definitely change the way it looks, because 1 has many forms. You could add 0, right? 0 has many forms. Plus 5 minus 5 is 0. Multiplied by 1, that you could think 5 over 5. Of course, they can get much more complex than that. Or you can just rewrite the expression. Rewrite, maybe rearrange, right? For example, if there's a 2 somewhere, this is overly simplified. This is not meant to be a comprehensive example. Just to give you an idea though, if there's a 2 in your left-hand side, you could rewrite 2 as 1 plus 1, right? And that might be beneficial in some way. Moving parts of the side around into different places could be useful. So the one method of proving an identity is to say that start with one of the two sides, maybe the left-hand side or the right-hand side, and manipulate it through a series of steps to where it becomes the other side. And then you've shown that they're equal. Another method is to maybe take the left-hand side, do some manipulations to it, and get something, right? Change the way it looks until you don't really see anything else you can do. You can't make it look like the right-hand side. You're getting stuck. But you can change the way it looks to something else. Then stop for a minute, go to the right-hand side, do some manipulations on it separately, and see if you can change it to the same something, right? Change that to where those two things are equal. If you can change both of the sides independently into the same expression, then the original expressions have to be equal. So this can be a very popular way of doing things if you can't always change one side directly into the other side, but you can instead change both sides into the same thing. So that's what you could do in this one, for example. The left-hand side, if we rewrite it, you could say tangent is sine of theta over cosine of theta. Secant is 1 over cosine of theta. Sorry. If you multiply those, you get sine of theta over cosine squared of theta, which is not the right-hand side. This does not look like the right-hand side, but I don't see what else I could do with this, so I'll stop there. Then I'll work on the right-hand side separately. The right-hand side is sine of theta times secant squared, which is 1 squared, or 1, over cosine squared. If I want to multiply these, I'd make sine into a fraction by putting it over 1, and now I'd multiply straight across. and I get sine of theta over cosine squared of theta, and we can see that the right hand side is manipulated into the same expression that the left hand side is, so the two sides are equal. Disproving an identity or a statement is to show that there's some value that doesn't make it true. So if I want to disprove that tangent of theta equals sine of theta, because this is definitely not always true, right? All I have to do is find one value of theta where it's not true. So if theta equals pi over 4, then tangent of theta would be tangent of pi over 4, which is 1. Sine of theta would be the sine of pi over 4, which is the square root of 2 over 2. And those two things are definitely not equal. So this statement is not true in general because there's at least one value of theta that it's not true. So we've disproved it.